eet105, chapter 7, example 13. Find the value of each resistor for the network below. So what they give you here is all these resistors are, multiples of each other, and they're all in parallel as shown. It gives you the source voltage and the current coming from the source. So in order to find the values of the resistors, you have to find the total resistance first. So R sub t equals 2R, in parallel with the other 2R, and also in parallel with R plus R, as written here. Okay, so R plus R equals 2R. So if you take this one first, this 2R in parallel with this 2R, it's going to be 2R times 2R, which is 4R squared, divided by 2R plus 2R, which is 4R. So you're going to be left with R. That's it from these two. It looks like this. 4R squared divided by 4R, like that, is going to equal R. And then you take that R, which is these two in parallel, and make it in parallel with this 2R. So you're going to get R times 2R, which is 2R squared in the numerator, divided by 2R plus R in the denominator, which is 3R. So that gives you 2R squared divided by 3R. R's cancel out. You get 2/3 R. So then to find the equivalent total resistance is just going to be the source current, source voltage divided by the source current. This is Ohm's law again. E equals IR. So R sub t equals 120 volts divided by 8 amps equals 15 ohms. You set the 15 ohms equivalent to the equivalent resistance you figured out in terms of R, and then you get that multiply both sides times 3, 2R equals 45, and then divide by 2, you get 22.5. So 2R equals 45. The reason why they did that is because this resistor's 2R, this one's 2R. So this is 45, 45. Each one of these R's is 22.5.